Hi, welcome to another episode of Paul on Power, Power System Design's podcast on the latest in power and power design. I'm your host, Alex Paul. Today I've got Tom Sporer. He's with Microchip, and we're going to talk about an area that's dear to some engineers, and that's active updates of high availability power supplies.
Okay.
Welcome to the show.
Thank you.
Well, it's a big issue, right? I mean, if it's a high availability system and you want to update it, don't you have to wait for it to be down?
Yeah, and that's always the challenge. I mean, we've got customers that are designing high availability systems. Servers come to mind where the customer wants to perhaps reflash, change the programming, the software in the power supply itself while the server's running, without taking the server offline, without the power supply going out of regulation.
Well, but I mean, that strikes me as a very difficult challenge, because if it's running, how can you update the commands that it's using?
It's definitely tricky. In a switch mode power supply, there is a small window where you can affect change of the software without affecting the output of the power supply. And so what we've done is developed a product that helps optimize for that eventuality of wanting to change that code while the supply is running.
Really? So you're literally timing it and catching those nano dead spaces between cycles to insert the code?
Oh yeah, fractions of a microsecond. I mean, you've got lots of time to get the new version of the code loaded to the controller while there's nothing else going on. Not while nothing else going on, but the supply is running out of one of your flash panels. You can upload a new image of code to the other flash panel in the background. No rush on that. But that switchover time from the old code to the new code is very critically timed.
Well, I could imagine, because you have to understand the system perfectly, understand the timing. Your timing's got to be spot on. And then, of course, your code segments have to be short enough to fit into those gaps.
You're switching over all of the code, so you've got a whole new version in the new code drop that has been loaded by your bootloader, say, over however loaded into the system. And then when you switch over, we switch from the one flash panel to the other flash panel and immediately start executing the new code. The first thing that new code does is maybe reinitialize some variables and things, but then it gets right back to its business of regulating that control loop.
Well, and what are some of the advantages to the end user? You were talking about server farms and the like. This ability then gives you what?
Well, as much as our power supply designers want to be careful in designing a power supply that's always going to work, they find over time things change in the field, and they may want to change their code for whatever reason. They don't know what it is that might need to be changed, so we need to give them that full flexibility. Things like changing the PM bus interface, adding commands or something, it's fairly straightforward because it's not as time critical. But changing something like the compensator control loop, which is very time critical, that's tough. And that's what people want to be able to do, possibly. They can't tell you why now, but they want to know they have that flexibility in the future.
Well, there are a lot of bad jokes that are, I'd rather have it and not need it than need it and not have it.
Exactly.
So
Yep.
For an engineer, you want to have as many tools as available as possible, right? Now, speaking of tools, I see you have this demo here. Why don't you tell us a little bit about the product itself and how you're addressing this?
Okay, so what we're demonstrating here is our MP-Lab starter kit for digital power. This is available on Microchip's website. This particular model is equipped with our new DSPIC 33EP GS family device, which has the capability for this live update. And what we're demonstrating here with the board is the board is actually got pre-programmed. This particular one's pre-programmed with two versions of the software, in partition 1 and partition 2. And it switches over every 30 seconds from one partition to the other partition. And what we're showing on the scope is that during that switchover time, we're maintaining full regulation.
Got it, got it. So what does the engineer need to know to implement this solution in their solution?
Really nothing. I mean, since the engineer doesn't know what he's going to want to change in the next version of the code, should there be the necessity